Welcome back to Area Diesel Service. Today we have a new and exciting collaborative effort with everybody's favorite YouTube creator, Diesel Creek. If you're not familiar with Diesel Creek, we'll drop you a link. Please go over there, check him out, and tell him that we sent you. I think you will find some very interesting and entertaining content over on Matt's channel. He is the original crusty, rusty, resurrection, will it run? We're talking about the auto car and the galleon road grader and all this other crusty stuff that he's pulled out of the weeds, resurrected, and brought us some of the best content on YouTube in that regards. Today, no exception. We have what is supposed to be the turbocharger off of another auction score. Don't know much of the story other than this is off of a GTH-1056. That is a Genie telehandler.
I picked this thing up at the auction a while back with the intent of flipping it and trying to make a few bucks because I was able to get it for what I consider a pretty good deal. But the trick was it was inoperable. I do have it licked, I think. I have some parts sent off to Area Diesel Service to be worked on. It does have a few hours on it. It's got, I think, around 10,000 hours on it, but overall in very good condition. Everything works, four-wheel drive works. The tires are foam filled, so you don't have to worry about flats. Doesn't seem to be any hydraulic leaks. It looks like a nice tight system. It carries 10,000 pounds and reaches out 56 feet. And this is an outrigger machine with a closed cab. So fairly desirable still, even though I think it's a 2010 or 12 model, something like that.
This is a big boy. This is of the 30,000 pound variety, and it is Perkins powered. Perkins 1104 turbocharged diesel engine in this machine. That is a 268 cubic inch 4.4 liter for those of you on the logical system, checking in at 120 horsepower. It is here because I think he got it out of the does not operate row at the auction, and he got it home, got it running, and found some issues. When he was removing the intake plumbing, he found oil in those pipes and in those pieces of plumbing, and he found when he went to turn the turbo to execute the farmer test that it was tight and binding of sorts. So this is a Garrett turbocharger. Garrett was the OEM supplier to Perkins for the first fit production line assembly. Area Diesel Service is a Garrett turbocharger master distributor. We are rebuilding and supplying these Garrett components all day, every day. This one, don't know the true condition. We really won't know that until we scatter it, but plan C and D, we've got brand new units in stock, so we can definitely help, but that wouldn't be very interesting content. We're going to slice this dude open, and we will perform our primary, secondary, initial assessment observation. Cat food for the guys in the back. What we have is a classic case of the Schmoo. This is some of the best Schmoo I've seen today. Thick, near grease-like. It is not fresh. It's been doing that for quite some time. I can see evidence of oil in the compressor discharge. When I give her the farmer test, it really feels pretty good. We'll never know until we crack it open and look inside, but I'm kind of wondering if this is not a secondary symptom of an underlying condition. Very often, if you have a turbocharger that is leaking oil and it passes the farmer test, if the wheels or the shaft is not excessively loose and it's making oil or pushing oil, you often will have an underlying condition presenting itself in your turbocharger, and it may not be the turbocharger's fault. The common things that we would see would be a restricted oil drain or excessive crankcase pressure. As the oil gravity drains away from the turbocharger, if it meets an obstruction, it will backfeed against the obstruction and it will pump oil out past the seals. The other thing that could potentially cause oil to come out of specifically the compressor housing, is if you have a restricted compressor inlet. So if the filter is caked with Schmoo, if the piping is collapsed, if there is a shop towel left in it, what you will find is that when you start to drive the turbo, you will draw a vacuum against that restriction, and you will draw oil out of the turbocharger past the seals. Plug drain, excessive crankcase pressure, restricted air inlet, and then clapped out, worn out turbo. This one at least is an ideal candidate for a turbocharger rebuild. I do not think we will have to completely replace it. It is intact. It is rusty, but it's not completely corroded and pitted and dead. So I think we've got a good candidate. This unit is a Perkins part number 2674A808. That is a Garrett 785 828-4 or -5004 for a new unit, or a -9004 for a reman unit. We are stocking in our inventory brand new authentic OEM Garrett unit for this. We see a lot of these. They put these little Perkins engines in all kinds of small equipment. For today's dose of theory and operation, we're going to talk specifically about the wastegate. If you want to see a generalization, a summary of what this component is and how it works, we'll drop you a link. We went into a fairly detailed what is this and what does it do when we did the turbocharger for large Marge. But for purposes of today's dose, we'll focus on the wastegates. What is a wastegate? Well, I would refer to it as a turbocharger overspeed protection device. Overspeed is one of the primary killers of turbochargers. If we can prevent them from experiencing an overspeed situation, then we can prolong their life, right? We can increase their longevity. Many years ago, well before my existence, the engineers at these places added this feature to some applications and some turbochargers. My boss would tell you that when this thing came out, it was like rocket surgery. It was big, big news. And all of the manufacturers that we worked with at that time were telling us that this device was so complex and complicated that we would never be able to service it, and that it would be something that would only be available and serviced by the manufacturers. Nothing is more motivating to area diesel service than to tell us we can't do something or can't figure something out. But I don't know what they were thinking, because this is about as simple of a device as there could be. I mean, there just ain't much happening here. A lot of people, when they hear the word wastegate, they think of this component that we're seeing here, and this is actually the wastegate actuator. Actual wastegate is in the bowels, and this is a pretty good example because you can see it very well on this turbocharger. Exhaust gas leaving the engine is first introduced to the turbocharger here, and then it scrolls around the housing and is introduced to the turbine wheel, which is what drives the turbocharger. The wastegate is this valve, this flapper right here that you see in the housing, and it is wasting the exhaust gas energy from being introduced to the turbine wheel. So we let it go from the inlet, right out of the engine, into the inlet, and when we open the wastegate, this valve opens and exhaust gas bypasses the turbine wheel and goes directly out to the exhaust system. So that energy, that flow, and that expansive energy is not being introduced to the turbine wheel. It's being wasted. It's being bypassed. It's being dumped out the exhaust. That valve, as you might have suspected, is controlled by the wastegate actuator. So you can see a rod here operating on this lever, and this lever directly connected to that flapper or that valve inside of the turbine housing. This actuator in this arrangement is boost controlled. So we take manifold pressure, boost pressure, turbocharger boost pressure, whatever you want to call it, and we plumb manifold pressure into this side of this actuator. We do that because boost pressure is roughly relevant to turbocharger speed. So as boost pressure increases, turbocharger speed increases roughly proportionately. Inside of this actuator, we have a diaphragm and we have a spring, okay? And this is specifically calibrated for this engine and this application based on how much boost pressure you get and how much spring pressure you have determines how much travel you get out of your actuator and your wastegate. So it is a varying degree of wastegate opening or closure, and it's based on boost pressure. So if we just barely break over that boost pressure, then we'll just barely open the valve. If we put it on the wood and we hit super high boost, this thing will react quickly, open up all the way, and bypass and dump and waste all of that exhaust gas. In an effort to control the speed at which the turbocharger is turning, and because we want the turbocharger to live as long as possible, we don't want it to experience an overspeed situation. Okay, so why don't you want overspeed? Like many other things, this thing has a maximum operating range of RPMs. And as RPMs increase, centrifugal force on these components increase, right? So if this thing's only engineered to operate at 75,000 RPMs and you pull the hose off your wastegate and you run it up to 150,000 RPMs, centrifugal force operating on those wheels they'll explode, right? They'll come apart and you'll have a catastrophic turbo failure. You will also find that you'll get a varying degree of frequency-induced vibrations at different speeds beyond the turbocharger's operating or optimal operating range. You may have seen compressor maps in the past. If you run it off of that map, you'll induce vibrations. Vibrations equate to wheel motion. Wheel motion equates to contact. Contact equates to imbalance. Imbalance aggravates all of those things, and the vicious cycle repeats until, boom, you got to call Area Diesel. They should have called it a turbo saver, and 90% of the market wouldn't think that this is a bad idea and wouldn't block it off or wouldn't ask for a non-wastegated turbo. If you are in a stock application and if you have stock goals and dreams, I would recommend that you leave this intact. It's there for a reason, and it is there for your benefit. If you are trying to blow smoke and melt tires, then I agree. Let's find you an application that is not wastegated, where we're not limiting the boost pressure, and where we're willing to blow up a turbo or two. But for most of us, this is a good thing. Or everybody take your wastegate off, blow your turbo up, give me a call. I've got one in stock for you. But I really don't wish that upon anyone. So we're going to tag this up. We're going to start a production order in the system. We're going to transfer this back to the turbo shop where they will perform a cleanup and a teardown and an inspection. And we will follow this along throughout the process. We'll probably give you one of those update style videos. Some of the guys in the turbo shop are a little bit camera shy, but I'm excited to see what we get into with this. I'm wondering if there's nothing wrong with it and if Matt doesn't have an underlying issue in a different system. That's it for now, but stay tuned. We're going to bring you along and see what we find.
This is from Diesel Creek. Looks like we're sucking in dirty air. See those fins? It shouldn't be that color. That's a good sign of just bad air, not clean air. I was told the complaint is that we got oil coming out of the discharge. It is wet in there. I'm going to take it apart here. Hopefully all goes well. These bolts are not a favorite. They're very small, so we'll see if they break or not. Marking the turbo, so later when I have to put it back together, I know the orientation. Although with this setup, it's pretty much, the housings are going to be set this way because the actuator is attached to the compressor housing. This is going to be fun to clean. We don't want to get glass or anything up in here. And then the way the rod comes down to turbine housing, these pretty much have to be where they're at. So the orientation really of anything that changed would be in your bearing housing. And we might as well check to see if the actuator even works. All right, our rod moved, easy lift off. Good, good, good. I whack the bolts to see if it will shock the bolts loose. When I tear down turbos, I like to remove the turbine housing first, rather than have the compressor wheel right now be exposed. I'm going to leave the studs in there. They look fine by looking at the threads. This isn't just going to come apart, so I'm going to have to give it the old whack. I'm going to hit it here and see what happens. That all looks great in there. A little turbine wheel. There's no brackets that hold the diffuser plate or the back plate down into it. It's just these bolts here with their wide flange bolt heads. Let's get those out. So here's a compressor housing, and here's of course a cartridge now. Downside of this style is this actuator is riveted in place. Put a cap on here, and we should be able to get it clean without having to hopefully get anything inside of the can, because that would just be bad. So what I'm going to do is put it in my vise. I've taken this apart, and it's just a little guy, so it doesn't take much. Probably maybe 30 inch-pounds, maybe, to detorque it. So we can see some of the, like the way the oil kind of like moves across the back. It's not great, but it's also like build up there. And then here on our shaft, we got some scoring. So there's debris in the oil is what we call it. So anyway, I'm going to take the piston ring off. It actually looks fine. It's not relaxed. When I call it relaxed, it would be like this. If we take pop a wheel off and we see that, there's a chance that it could have too much rubbage. It got hot, and the metal can only take so much heat itself, wear down. If it's relaxed, then oil would be able to get past it. But everything past this way on the turbine wheel is city, so real good. What I'm looking at here right now is right up in here. It's not great. We'll clean this up. We'll run a buff wheel through it and see. But I can see a line. Right up in here. It might be really hard to capture on camera. It's a good sign. Well, it's a bad sign, but it's a good sign that be an O-ring right here. I call these just washers. They're part of the thrust system. It's kind of discolored, and we got rings, so scoring. And then here's a spacer, and then another washer to create. In this system, it would be like a 360. That press bearing. See the highlighting out. Not so bad on that side. And there's this neat little pin in these models. There's a groove cut in the journal bearing right here, and it doesn't allow the journal bearing to spin. So the journal bearing is stationary for any type of the OD or of the journal bearing here. So it's kind of hard to judge the outside of the bearings because they don't move, but the inside, if we were able to see, we would see where the highlights, the scoring is at. That matches the wheel. You can kind of see wear lines as whatever was in there came in through the oil feed holes, and then got spun around with the wheel. Put the turbine housing, backplate, bearing housing, into the oven. The compressor housing will not be baked because they will destroy that actuator. It will get a different treatment for cleaning up. So here we are out in the dirty room. Here's said oven. I put all the parts in the bowl, mixed them up with the eggs and the batter and all that cool stuff. And cooked it for a couple of hours at 600 degrees. And that was last night, and so it's been close to 12 hours. So here's our parts, good and baked, ready to be blasted. We'll see how much of that I can get on film.
Operation Cleanup and Inspect is complete. We're going to walk you through some of the findings here. Everything looked pretty good, but there's a couple issues, and we'll talk about some options on how to get that stuff straightened out. We will start on the exhaust end. This is turbine housing, and you can see it has now been blasted and cleaned up. We've faced it here where it seals to the manifold, and we have inspected everything to make sure that this is good, and it is. It's actually in really good condition. One of the places we pay close attention to is down here in what we call the tongue. So this is kind of where the exhaust heat is most intense and most choked down. And if you're going to find a crack, you'll generally find it there, but we see nothing. The wastegate seat and valve looks fantastic. So turbine housing checks out very, very nice. The turbine wheel sits in here like such, right? And as that exhaust gas comes around, it drives the turbine, which is what runs the turbo. It's pretty faint. I don't know if we'll pick it up on camera. This is a journal from here to here, and this is a journal from here to here. That's where the journal bearing rides. This dude, as such. And it's very faint, but it's worn there, which is pretty normal, really, and not a big deal. The piston ring area is pretty square and true. We have no foreign object anywhere else, so basically this would be a candidate for a undersized grind and undersized bearing. No big deal there. The bearing housing in which the turbine wheel and journal bearing reside is in very good condition. So oil inlet here, and you can see there are some passages and annulus in the casting, different drillings where the oil is introduced to the bearing, and then here is where it gravity drains back out and back into the sump. So this component checked out perfectly fine, ready to go. Turbine wheel sits in there, something like that. This bearing gets installed like such and pinned here. And then we also have the thrust bearing, what would be controlling axial play inside of the turbocharger. It looks fantastic. Very, very faint evidence of where the other components live, but no real signs of wear. Right? It lives in the bearing housing like so. The back plate is where we see some damage. The back plate mounts up to the bearing housing like such and captures that thrust bearing. And again, I don't know if we'll pick it up on camera. This turbo was leaking oil on the compressor stage. So the compressor wheel fits up here, and then the compressor housing makes up the compressor stage. This back plate mounts to the bearing housing, and that's what the compressor housing attaches to. And the slinger fits in the back of it. So this flinger rides on the compressor wheel, and then it has a butt cut piston ring. So we've had the turbo leak oil debate many times, right? They don't really have a perfect seal like a hydraulic cylinder. They have a butt cut piston ring, and I like to say that it suggests that oil doesn't leak, but it really doesn't positively seal the oil from leaking. It's the differentials and pressures inside of the turbo that keep the oil inside of the turbo. Anyway, that piston ring fits on that slinger, and it's deformed from when we removed it, and it's a normal service item anyway. And then that doodad snaps in the back of the seal plate or back plate, and that sits on there. and I don't know if we're picking it up, but where that piston ring rides inside of this seal plate, back plate, is scored. Not abnormal. Standard operating procedure would be to machine and hone that out, and then we would get an oversized piston ring that would make up the difference, restoring factory clearance specifications. This needs machined. We're going to need a non-standard piston ring. No big deal. Compressor housing is in very good condition. Everything cleaned up just fine. Compressor wheel rides in the bore there. And then heat shield, clamp plates. So this will be our normal overhaul kit. New journal bearing, new thrust bearing, new flinger, and then new thrust components, new bolts, all of the piston rings, O-rings, clamp plates, right? Everything that you need to go back together in a standard dimension turbocharger. We're going to have to do some machine work on this one, a little bit of repair work. We'll have to come up with some custom components. So we will go to the drawing board. Before we go to the drawing board, perhaps a little bit of failure analysis. Why did this turbo leak? Why did it show up? And it's really in pretty good condition. I'm not sure that the wear that we're seeing on these components is responsible for the oil leaking. I know that Eli told me when he tore this turbo down that he found significant evidence of dirt or unfiltered air on this side of the compressor wheel. Compressor wheel fits up in here, right? And then plumbing and air filter and fresh air inlet. So this is where clean filtered air should be being introduced to the turbocharger. And it was caked in Schmoo on all of the inducer fins. We don't see a significant smoking gun. My best guess at this point would be that the filtered air system, the air inlet system, was restricted. When that compressor draws against that restricted air inlet, you know, this is more restrictive than it should be because the filter's caked with crap. So it'll draw a vacuum against that restriction, almost like putting your hand over it, right? It'll draw a vacuum against it, and when it does that, it'll literally pull oil past that butt cut piston rings. I think we do find a little bit of wear, but I'm not sure I can attribute the leaking oil to the wear that we see. I think it might be a filtration issue or a maintenance issue or deferred maintenance, as we sometimes like to call it, but we're not seeing just a completely trashed or torn up turbocharger. That's what we've got. Now we'll go to the drawing board, figure out what the best approach is, and then we'll meet you back. Game plan complete, and here's what we found. The cost to machine the turbine wheel, machine the back plate, the cost of the standard kit plus the oversized journal bearing and piston ring exceeded that of what we call a cartridge. So we have on the shelf a brand new Garrett authentic OEM cartridge for this turbocharger. And this is an ideal solution. And in this situation, the most cost-effective solution. Just like Christmas. Cartridge, or as some folks refer to it, CHRA, which is center housing and rotating assembly. So this unit comes from the OEM manufacturer, right? Garrett manufactured this turbo. This is a Garrett OEM cartridge. Area Diesel Service is a Garrett master distributor. And this cartridge, factory assembled, brand new, all brand new components, was about $300. So this cartridge is significantly less expensive than the machine work and the non-standard subcomponents and the labor to rebuild the original turbocharger. So, and this is something you can do yourself in the field if your end housings are in good condition, right? You take them apart, clean them up, whole brand new cartridge drops in the turbine housing, and then compressor housing drops over it, And there, bang, brand new turbo. The only thing you're reusing are these castings, the end housings, but they're boat anchors, right? They don't do anything anyway. So as long as they're not all chooched up on the bore, this is going to be effectively a brand new turbocharger. And again, Matt's end housings were in fantastic condition. We're going to bang this in real quick. We'll let you watch, and then we'll meet you back at the parts counter. There, a couple of dingers. Before he disassembled this turbocharger, he marked it, and those marks indicate the alignment of the oil inlet. So before we tear them apart, we'll ping them. That way when they go back out, the orientation is set the same way so the customer can reinstall it without having to align the housing. All right, you'll see him go star pattern, right? Just like you're putting your wheel back on. We want this thing to draw in proper and centered. You'll watch him throughout the process of reassembly. He'll spin it periodically and just make sure that nothing is bound. Make sure all of the rotating assembly stays free. Okay, so now cartridge has been reinstalled into the compressor housing. We also refer to that as a super core, yes. Little dinger there. Again, that's the orientation mark. Gonna line that up with the dinger there and with the oil inlet. Clamp plate, a couple of bolts. So same thing, he's kind of working his way around, back and forth, crossing, making sure that this thing draws up centered, and you'll see him give her a spin every once in a while. Yeah, so we talked about wastegates a little bit at the counter. We're going to give you a little demonstration here, and we'll replicate on the bench. And this is part of the rebuild, is to make sure that the actuator is calibrated proper. So this is going to replicate boost pressure, right? So we just have a regulator. So we've got effectively no boost going to her right now. And you watch, we're going to dial up some boost, and watch this arm down here.
That's pretty much max.
This one is not adjustable, but many times you'll see threaded turnbuckle, and you can change the pressure at which it opens. And again, you can see when boost pressure comes up, that rod comes out and it operates on that lever, and that lever unseats that valve, and that valve lets exhaust bypass the turbine wheel and just go straight out the muffler. And then a retainer clip, E-clip. Okay, plug the drain, keep it from getting any foreign object. Give her a little pre-lube. It's a highly scientific concoction of 15W40 and Slick 50, Motor Honey.
I like Lucas.
Lucas.
Lucas is what I like.
Thick.
Holds my parts together.
This is new Schmoo, so this is before exposure to engine and temperature. Pre-lube is mission critical. Yeah. He's walking it around and you can watch it. So he's giving her the feel, right? Checking the thrust in play. There she is, completely rebuilt in the absolute best fashion that we can do, which is brand new cartridge. The end housing's off, cleaned them up, stuffed completely brand new guts inside of her, and she's ready to rock. The last thing we're going to do is make a tag to identify this unit, right? So we're going to track this number with a part number and with a serial number so that we can tell what was done, who did it, when and why, and for who. Once we get that done, this unit will be completely complete, and then we'll meet you at the parts counter. Mission complete. Turbo rebuild has been taken care of. You saw what we went through back there. We don't have to dive back into everything, but we will hit on basically the three different options that could have transpired here. First option would have been in stock, brand new Garrett authentic OEM turbocharger off of the shelf. If that would have been the route we would have gone, right, if this would have been an urgent machine down, that turbo is $1342. Again, brand new OEM Garrett unit, the best thing you can get for this situation. If money is no object, that's the best thing to go, right? Brand new, in stock, ship it today, have it tomorrow. Option 2 would have been the overhaul of this component, of his original component. We talked about what would have gone into that, machine work and custom components. No big deal, that's what we do. But in this situation, it was not the economical route. Overhaul would have been about $8.25 for the new parts and the machine work and the labor to put it back together. The option that we did go with was, again, brand new Garrett cartridge out of stock at Area Diesel Service. New cartridge, $295.57. We had 3 hours of labor. That was the teardown, cleanup, inspection, and reassembly of the turbocharger. 3 hours at $1.25 for $375, and that gives us a total of $670 plus tax and shipping, maybe some other small odds and ends. $700 to put a brand new cartridge in this turbocharger. Or if you are mechanically inclined, you can buy the cartridge again yourself for $300. Take it apart, put your end housings back on, and you're effectively a brand new turbo. So those are the 3 different options, the 3 different answers to the $1 million question. We'll pop out the brand new unit just for comparative purposes. Okay, so no studs in the brand new unit, but other than that, part numbers line up, actuator looks correct, inlet is the same, and the exhaust outlet and bolt pattern are the same. $1342.95 brand new, or $670 with a new cartridge installed. So let us know your thoughts down in the comments. Which way would you go? Brand new everything, or completely brand new cartridge in reused housings for half the money? In the rare event that you did not come to us from Diesel Creek, please go over there and check him out. He's got some of the best crusty, rusty resurrection content on all of the YouTubes, and you can watch this turbocharger get reinstalled and see if our repair was effective. If you find yourself fighting the Schmoo, please don't hesitate to reach out and let us know. We are diesel engine experts. We specialize in turbochargers and diesel fuel injection. We provide many other diesel engine components. We're talking overhaul kits, starters and alternators, after treatment electronics and sensors, wiring and lines. If it's on a diesel engine, from lawnmower to locomotive, we're here trying to help. And if you're not in need of any diesel engine components, but you do want to support us, we have had a lot of requests for a shirt, which is now up and live in our merch store. We should have repaired now the shipping prices. Our website was asking more for the shipping than we were for the shirt, and I think we got that fixed up. We should have a $10 flat rate shipping on all of your swag orders. If you want to join the band, if you are a Schmoo Fighter or an aspiring Schmoo Fighter, we'll drop you a link. That's it for now. Thanks for watching.